I'm at Reef-corner, a specialist in coral.
Hi everybody, I'm Tori from Scuba for Families, and today I'm really pleased to tell you that I'm with Joey from Reef-corner.
Yeah, hi, welcome. Hi.
Thank you. Joey has one of the largest supplying shops of coral in Europe, and with over 1,000 different varieties of coral just here in the shop. We're going to talk about what is a coral and how do we care for a coral so that it grows into something beautiful and something that you want in your tank at home. Tell me, Joey, what is a coral?
A coral is a live animal, not a plant. Most of the people think it is a plant, but it is a live animal. It has a symbiotic relation in between the coral and his algae called zooxanthellae, and they exchange nutrients to each other.
And so, like with any living animal, you need the basics to survive. You need energy, you need water, you need air, you need light, you need nutrients, because you're feeding the animal.
Yeah, and that's completely different than it is in the wild, because it is a closed system. Keeping a coral is a little bit more difficult than it is in the ocean. It needs food, it needs trace elements, it needs the exact amount of light, and it needs to be well looked after.
Yes. So let's go into the 7 key things we need in order to grow and care for a living animal, which is the coral. So the first thing that we're going to talk about is water filtration.
Yeah, water filtration, that's a very broad topic. Because keeping a coral as a hobbyist is still fairly new, meaning that it's a hobby from the last 30 to 40 years. And keeping corals is still something, there's not a lot of knowledge how to keep a coral in a closed environment. The filtration system is for us the heart of a system, and it means if you want to keep corals, you cannot cut costs on certain parts of the technique. The most important thing is a protein skimmer, and a protein skimmer is just a basic pump, and the pump mixes air and you skim off a part of the proteins. And by skimming off a part of the proteins, you're also skimming off some of the detritus, so organics that are in the water column. And by skimming off the proteins, you're in between the entire nitrous circle. We take a part out, so we prevent it to build up in the system.
With your pump system and the movement of water, that's generating oxygen within the water itself, which is then feeding the coral.
By aerating the water by the skimmer, it's mixing, you're also expelling the CO2 gases. When we keep CO2 in the system without preventing the CO2 to build up, the pH goes lower. So we want to keep the pH at the normal level, and we do that by aerating the water by the protein skimmer.
So the algae of the coral, which feeds the actual animal, the polyp, that's done through the light, through photosynthesis, which is the chlorophyll within the plant is feeding the animal, which then gives it the glucose and then as a byproduct, oxygen comes out. The second point is there has to be the exact temperature or a temperature range to keep corals. Otherwise, as you see in the world, we have global warming and coral bleaching right now, which is aggravating the algae, and the polyp itself kick the algae away, and you get bleached coral because the temperature is too high. So let's talk about how we keep coral in a tank, and what's the best temperature.
Keeping corals in a closed environment is a little bit, again, a little bit different than in the ocean. In the ocean, when we have temperatures deviations, it is often a trigger for corals to expel the zooxanthellae, because the zooxanthellae are not happy and they're going to find a better place to live. In a closed environment, we can play with temperature. It's strange, but we can play, for example, within 23 to 27 degrees without them bleaching, strangely. So in nature, there are many things involved by bleaching a coral except for temperature. We keep it around 24 degrees, and 24 degrees is on the lower side. And on the reefs, maybe you have 25 to 28 during the high season. We keep it on 24 degrees, and that's just the more temperature, the more power we have to put in the water to heat the water.
Yes.
So 24 degrees for us is an average we try to keep almost constantly.
Okay, and that's quite economical for the electricity and everything like that.
Yeah, 24 degrees is the lower end of what we like to see, but it is good to keep the corals and grow the corals.
Yeah, and do you still find you're getting a centimetre of growth a year with 24?
Depends on the species. Yeah, we have some species that would grow, for example, from a small frag, it would grow to at least 10 times the size within a half a year, and we have species that grow, for example, a half a centimeter within a year. So it grows so slow that you even cannot see it growing.
Okay.
Yeah.
So the third thing that you need to have to grow coral is the right salinity. So the right amount of salt within the water can really affect the growth of corals.
Yeah, salinity is the measurement of all the elements within the water. So we call it salinity because it gives us a measurement of the amount of salt in the water.
Yeah.
But we look more to the separate ingredients like calcium. The biggest elements are calcium, magnesium, gallium, all those elements, and then we go to the trace elements. Specific effects that you have, for example, calcium and magnesium lets the coral build their skeleton.
Yeah.
But when they build a skeleton, they also need, for example, strontium and some minor elements. Yeah. So we try to measure all the elements in the water by a laboratory test.
Okay.
And then we see all these minor elements in the water, and we try to adjust our water according to the natural sea levels.
So if you were growing coral as a hobbyist, how many times a week would you test your water in your tank?
As a beginning hobbyist, I would suggest them to do at least 3 times a week a test to have an idea how the tank develops and the biology of the tank. And when they have an established reef, let's say more than half a year to a year, then I would say once a week should be enough.
Right, okay. And then you can buy the different types of tests to do it, like a KH test, a nitrate test, phosphorate test.
The most important ones we can do ourselves with a hobby test. It's just titration. You take a liquid and you add a product, and it forms a dye after a certain amount of time. And then we look at the chart, and then we can see the amount of X product. And
would you say that most people that are having problems with corals in their tank is due to different imbalance of chemicals? In
imbalance in biology, chemistry, light. That's something that we discuss with customers that have problems. Is when they think they have all the main parameters in check, still it isn't the key to grow corals. You also have to look at the intensity of the light, the colors of the light. And then back to the filtration system. Everything is important.
So that brings us to the fourth point. We really need light. How important is light for coral?
As they do photosynthesis, synthetic, they do need good light. And meaning light, they can grow under almost all the lights we have. The lights are very important, and also the light intensity. Most of the corals come from a depth lower than 20 meters on the water surface, so they never saw any white light because the light in the ocean is filtered out depending on the depth. And most of the corals at this moment, they come from a depth more than 20 to, let's say, 50 meters depth. So we keep everything almost on the blue light.
Which would be the natural color you would see in the ocean at those depths.
We have LEDs. LEDs are the newest in this hobby. In the past, they used metal halides. Metal halides are the lights they use in a football stadium because they emit a lot of power, but they didn't have the right spectrum. And then a few years later, the hobby switched to T5 light bulbs. And that's still the best light, but it isn't economically at this moment because you have to change your lights every few months, and the power consumption is very high.
Right.
That's why they have LEDs now. In our farm, we all have metal halide and T5.
So why do you have that as opposed to in the shop?
If you want to grow corals, you want to give the best light they can have to grow. And that's still T5 and metal halides.
Okay.
So the farm, the power consumption in the farm is a lot more than this, but a shop itself is more to keep the coral and to keep it healthy.
Okay.
And in the farm, we do it all the way around. Yeah.
Where you're concentrating on growing?
Yeah.
Okay.
Yeah. Keeping corals and growing corals is different.
So what's the difference in growth rate then if you have a white T5 light compared to a blue LED light?
I think the grow rate in our farm is at least 2 times as fast as we have in those systems.
Wow, so light really makes a big difference.
Yeah, it makes a big difference as a coral farm, but in the shop you want to display all the colors that the coral has.
Yeah, sure.
And that is easily done with a blue LED and not with a metal halide. So if we would have metal halides, the colors of the coral will be dull.
Yes.
So we have blue LEDs to showcase the real colors.
Yeah, so let's talk about the 5th point that we need is food. I don't know about you, but if I don't get food, I get very grumpy.
Yeah, we'll starve.
Yeah, I need my food.
Yeah.
So do corals. So what food do we give them?
Yeah, again, a big difference in between nature. We try to give all the food possible to the corals we can. The thing is, in a closed environment, when you give certain kinds of food, for example, dried food, you need to have the best quality of dry food.
Yeah.
Because when I do not overfeeding the corals, you can feed the corals on different ways. We can give live phytoplankton or zooplankton. Often it's phytoplankton. Not all the corals eat phytoplankton. Also, we could try to give zooplankton, and then we have different species of corals that eat zooplankton. But we in our shop, we don't feed the corals directly, but we feed the fish.
Right.
We feed the fish often,
Yeah.
and we also have an excess of food in the water column flowing around, and at a certain point the coral will take the food out of the column.
Because corals get their initial glucose from the light through photosynthesis, through the algae giving them the food, how much additional food then via these zooplanktons that you give do you give? I mean, how do you find the balance between the natural food, which is glucose, and what you give, which is the additional zooplankton?
Yeah, I don't know the perfect ratio.
Right.
And I think that scientists are still in the beginning of exploring how a coral works.
Right.
Yeah. Many farms in the US, they do actively farm zooplankton or phytoplankton to continuously dosing the systems.
Yeah.
We don't.
No.
We just rely on the basic elements, the chemical elements like calcium, magnesium, and to keep those things in check is already half won.
Yes.
Yep.
Yes, and obviously, like any animal, you take food in and then you have waste that goes out. So how do you deal with the waste? Is that all processed through your skimmer?
The protein skimmer is the main filtration device that takes out the proteins.
Yeah.
Yeah. Lately, there are new devices, for example, fleece filters. Those are just square boxes with a fleece, cotton fleece, and the water is filtered to the fleece. We don't use it anymore because we want to have as much as food sources in the water as possible, and a fleece filter will take too much out.
Okay.
For a hobbyist at home, it is beneficial because you have crystal clear water, but we keep everything a little bit more dirty.
So the 6th point I want to talk about is health of a coral. Everybody gets sick sometimes. So when a coral becomes sick, how do we ensure that we get it back to health?
Yeah. If we have a sick coral inside the system, we first evaluate the problem. If the coral has, for example, tissue loss, we have a bandsaw, we cut off the tissue, the dead tissue, and we treat. We use some kind of antibiotic. We put the coral in an antibiotic solution for several hours to help it battle the pathogens. Often when a coral dies or is unhealthy, it could be a bad pathogen, or for example, we have a fish that eats corals, and they nibble on the corals and the flesh is exposed. And at the moment the flesh is exposed in a closed system, you could have some algae growth on the skeleton. Right. And the moment you have algae growth, then often it is the end of the coral.
Okay. The difference between the two tanks is, where would you put one with antibiotics in? How would you manage that?
We always place our corals depending on the light intensity. Okay. We cannot put a coral that is low light in a high light environment. Otherwise it would bleach, it would expel the Zoontactella. So often we put the sick coral back in the system. Right. In the same system at exact the same spot, then we're pretty sure that it's getting the same amount of light, same amount of flow. Yes. We have two systems. This one is more leaning towards SPS, hard corals, hard stony corals. And this one is leaning more to LPS, large polyp stony corals, and they are more relying on food and good light. Yeah.
Okay, great. And how about parasites that you find on corals? I see you've got fish swimming in amongst your corals. Are they to take the parasites away?
They take a part of the parasites away, but not everything. The system is so big that the fishes alone cannot handle pests. Right. It's up to us as a shop. When we import corals, we import all the corals ourselves from Indonesia. We have to do an anti-parasitic dip with a product that it doesn't kill the parasite, but it stunks. They become paralyzed. Yes. Yeah, and then we rinse the corals and put it in the system. Okay. If we do find a pest on a coral, we first would inspect the other corals to see if there are also a pest on the other corals. Otherwise, we would quarantine the single coral inside some kind of pesticide for a day, and then we put it back in the system. Oh, okay. Otherwise, we would treat the entire system. Treating the entire system is very dangerous because if you add a product that kills pests, it will also kill other beneficial things. Yes, that's right. Yeah. So we always try to do dipping corals against pests outside of the systems.
Yeah, that's sensible. So the seventh thing that is really necessary when you care for a coral is the correct placement in the tank. So the location has to be right. Yep. Because how I understand it is if you have placed corals, some corals will eat another coral if they're not the same genome, the same species.
Yeah, they're not exactly eating each other, but they are attacking each other. Right. So they are battling for space. Yeah. Because in nature, when the eggs settle on the reefs, they don't choose the spot themselves, it's just by luck. Yeah. During the night, some of the corals, they do have long fighting tentacles. They just float around, and when they touch another coral, they will extend all the other fighting tentacles and they try to reach the coral and poison other coral. And those happen. It also depends on the region. If, for example, if you have a coral from Australia and you have one from Indonesia, it could be exactly the same species or lookalikes, and you put them together too close, one will try to kill the other one.
So unless it's the same gene pool, exactly the same gene pool, they could attack another one. Yeah. So it's important, I guess, when you propagate coral, that you use the same gene pool.
Yeah, the thing with, in nature, you're mixing DNAs. Yeah. What we do in a closed environment, we are not mixing DNAs. We are cutting corals. Yeah. So
it have exactly the same DNA.
Yeah, it have exactly the same DNA, meaning that we can save space by putting a lot of fracked corals close to each other, touching each other.
Yeah. Yeah, because they won't attack because they've got the same gene.
Same gene. Yeah.
Yeah. Okay.
But it is still, when we have an import, for example, 500 corals, we have to put it in the system. Yeah. We do it as we think, meaning that we will sort different species together, But the day afterwards, often we have to relocate all the corals because we see this one stung that coral, and then we have to move. Yeah. So that's why when you see a system like this, we have a lot of space in between the corals just to prevent them killing each other.
Sure.
Yeah.
Okay, so perhaps Joey, you could show me a coral and maybe a Euphilia, or what do you recommend?
Yeah, I think Euphilia is a nice example of an easy to keep coral with some nice colors.
They're beautiful.
Yeah, they're beautiful. They like to be hammered with flow.
Right.
And a Euphilia is easy to keep, meaning that they can handle low flow, high flow, low lights, high lights. They're very a hybrid coral. Yeah.
Okay. And their tentacles are just reaching out to grab particles in the water.
Yeah, but they have a mouth, so if you would feed them with a dried powder or something, they would retract all the tentacles and try to move the food to the mouth. Those, as you can see here, those are Euphilias. This is a completely different species that's also Euphilia.
Oh, could we have a look at one?
Yeah, sure, I will take one. I will take this nice yellow-greenish one.
I love how all the tentacles are moving.
Yeah.
And the very fine tip is a blue edge or pink edge.
Yeah, this one is a mixture. It has blue tips and orange pink tips. But there are also many other coral variations, for example, those.
Yeah, that's beautiful, reds and bronze.
Yeah. They're all different species. Those are not, let's say, homegrown.
Right.
Those are big colonies we import.
Okay.
Those colonies have, for example, 15 heads, and we do separate the heads and glue it on a frag plug. Otherwise, those kind of corals in this size is just too expensive.
Right.
Yeah.
So how much would one of these cost?
Depending on the color and how rare the piece itself is, because they don't have to be beautiful to be rare. Some of the colors are so rare, and that also indicates the price often. This will go in between, let's say the yellowish one will be in, let's say, €79, up to down to €49 for the more basic, easy to keep ones.
Yeah.
And we also have Euphilias that goes in the price range up to €250 a head.
Wow.
Yeah.
Great. So, out of all the 7 different things we've talked about to care for coral, is there any one that stands out?
For us, they are all equally important.
Right.
Yeah. If we have all those 7 points in check, because we pay so much attention to those 7 points, that's why we could keep such a broad spectrum of corals in our tanks. Yeah.
Fantastic. Well, thanks so much for your
Thank
time.
you.
And it's such a wonderful experience to be in a shop that has such a wide variety of coral species. And it's these different shops that can keep the coral species alive going forward, as well as the coral conservation projects. It's these guys that are doing such a great job to keep the diversification of species going. So thank you.
Yeah, thank you. Thank you for your visit.
Thanks. And please subscribe if you like this episode on how to care for coral.